Hi there. Could you please assist me with something? We want to know, this desk here, what is the shape of its surface?
This shape is a trapezium. Yeah.
For me, I think this shape of the table is in the shape of a rhombus.
Thank you. Thank you. Excuse me. Could you join me? What do you think the shape of this desk surface is?
I think it's a trapezium.
Thank you. Thank you. I think I need about 2 more people just to make sure. Oh, there people go. Hi guys, could you please join me? What do you think the shape of this surface is?
I think the shape of the shape is a kite.
Okay. What do you think it is?
I think the shape is a rhombus.
Thank you. Thank you both very much. Hi viewers, you know why I asked them, don't you? That's right, we are still busy with our series on JSC mathematics. This shape is a trapezium, and today we'll work out how to calculate its area and perimeter like we did with all the shapes we discussed earlier in this series. After watching this lesson, you should be able to work out a logical way to derive a formula for both the area and the perimeter of a trapezium. In an exam later on, you might be required to derive the formulae for the area and perimeter of a trapezium and apply the formulae to calculate the area and perimeter of a trapezium. So, get your pencil and paper and let's get started. Firstly, let us make sure you understand what a trapezium looks like and where we find them in real life. A trapezium is a 4-sided, flat shape with straight sides. So far, it sounds just like the parallelogram, right? But no, look again. In a parallelogram, both pairs of opposite sides are parallel and the same length. It looks a bit like a skew rectangle. The trapezium, however, has only one pair of opposite sides parallel. Sometimes the sides that are not parallel are equal in length. In this case, the trapezium is called an isosceles trapezium. An isosceles trapezium can be made from an isosceles triangle which always has 2 equal sides and 2 equal base angles. If a smaller triangle is removed so that the base is parallel to the original base, an isosceles trapezium is left. An isosceles trapezium has special properties. The parallel sides are called the bases, and the other 2 sides are the legs of the trapezium. The distance at right angles between one base and the other can be called the altitude. So, what was known as the height of the parallelogram at a right angle to the base can also be called the altitude. It's the same as height. To sum up, a trapezium is a quadrilateral that has only one pair of parallel sides. In fact, the sides can all be different lengths. Now, to be honest, there are not as many trapezium shapes in the real world as there are some other shapes. This is because of the asymmetrical shape. I can think of a box of popcorn, and of course, these computer tables, specially designed windows like this one, and so on. Can you think of any?
I don't really know why the 2 of you have asked for extra lessons. You guys have been doing so well this week.
Thank you, ma'am. We've really been enjoying the topic so far.
Yes, ma'am, but we assumed that we would have to cut out shapes again with the trapezium, and we cannot imagine how that would work.
Well, I'll help you with pleasure, of course. Do you have your pencils and things ready?
Yes, ma'am. Everything is here on the desk.
And you guys are so intimidated by a trapezium that you don't even realize that that piece of paper lying on your desk is cut out in a trapezium shape.
What?
What?
Yes. Have a look at it. You see the baseline here runs parallel to the top line, and the two sides become wider as they go up. They are not parallel to one another.
So this shape is a trapezium shape. Now I will always remember it.
Then let's begin. Sally, Ben, you each draw a trapezium shape. They should be exactly the same size and shape. Firstly, you can draw a rectangle with 1 centimeter square. It just helps to draw the shapes much more accurately.
Okay, Ben, let's say the long side of the rectangle is 8 centimeters and the short side is 3 centimeters.
Done, ma'am. Are we going to cut them out again?
Yes. Look, if you take away, say, 2 squares on either side at the bottom, you will end up with something that looks exactly like the piece of paper lying on top of your desk.
That's right.
Let's add 2 more rows. So you will each draw a rectangle with 8 blocks in a row and 5 rows. That's 40 squares in total. Now each of you cut out your trapezium. Let's say this time you take away 2 squares on each side at the top. We're now drawing 2 trapeziums standing up like a mountain and not like the piece of paper lying on top of your desk.
Yes, ma'am.
Next step, cut them out.
Oh, wow. Now I see. The 2 trapeziums are exactly the same size and shape. And if you flip one over on its head alongside the other, together they make a parallelogram.
This is so cool. When we put the second trapezium next to the first one, flipped upside down, they make a parallelogram.
I never knew one could do this.
I'm glad to see the 2 of you are beginning to see how it works. As long as the 2 trapeziums are exactly the same size, they can be combined to make a parallelogram. Now I'm sure you have an idea about how to work out the perimeter and the area of the trapezium.
Yes, ma'am.
In fact, I'm surprised that you have not noticed that the desks that you are working on are in that shape. Take a closer look.
Wow! Look at that! We've been working on trapeziums on a desk shaped like a trapezium.
My table is just turned the other way around. These 2 also make a parallelogram.
You see, math is all around us all the time.
Viewers, do you still remember? The perimeter of a shape is the distance around it. For example, looking at the trapezium on the screen, if we start from P and move around it in a clockwise direction back to where we started, the full distance we would cover is the perimeter. The perimeter is the distance around the shape. It is the sum of all the sides. We can say the formula for this trapezium on the screen would be perimeter equals A plus B plus C plus D, if A, B, C, and D are the lengths of the sides. For example, if the sides of a trapezium had lengths of 5 centimeters, 12 centimeters, 4 centimeters, and 15 centimeters, then the perimeter would be equal to 5 centimeters plus 12 centimeters plus 4 centimeters plus 15 centimeters, which adds up to 36 centimeters. The unit is centimeters because it is just a distance.
But ma'am, is there a specific formula for finding the perimeter of a trapezium?
The solution is quite simple. We just have to add up the length of all the sides.
Here, Ben, we've got the length of the top line. It is 4 centimeters, and the bottom line is 8 centimeters. So, we can say the perimeter of a trapezium is side 1 plus side 2 plus side 3 plus side 4.
I measured the sloping sides first. The first side here is 6.4 centimeters. The other side looks like 6.4 centimeters.
Okay, I'll calculate the perimeter by adding up the lengths of all the sides together. 8 plus 6.4 plus 4 plus 6.4 equals 24.8 centimeters. That's the perimeter if I'm correct.
Yes, you are.
But what do we do if all the sides are not given? Like the example you gave us to do, ma'am. It's really hard. We only have the height and the parallel sides.
Yes, the height is given, but the lengths of the two sides are missing.
Have a look, you two. Do you see the height is perpendicular to the base? This means there is a right angle triangle.
Oh,
And haven't you learned a method to find the missing side in a right angle triangle?
Yes, we did, with Pythagoras' theorem.
That's right. So to find the length of the one side, we should apply the theorem of Pythagoras. This side we want is the sloping side of the triangle, which means it is the hypotenuse of the triangle.
I'm afraid I've forgotten everything about the hypotenuse and Pythagoras.
The theorem says that the hypotenuse squared is equal to the sum of the other two sides squared.
Let me help you. The calculation will work as follows. The height is 12 centimeters. The base is 9 centimeters. The hypotenuse squared equals 9 squared plus 12 squared. 9 squared is 81 and 12 squared is 144. Adding up these two gives us 225 centimeter squares. But this is not the final answer, remember? The hypotenuse is still squared, and we do not want the squared amount, but the length of the actual side, so we calculate the square root of 225. My calculator gives it as 15.
Okay, so the missing side is then 15 centimeters. Now can we calculate the perimeter of the trapezium?
Are you sure we have enough information, Sally?
Oh no, we only know the lengths of the three sides of the trapezium. I think we can do the same on the other side, but there is a problem. I know there is a right angle, but the length of the base of the triangle is not given. The height is the same, of course, so at least we have that.
Oh, Sally, look. The shape in the middle is a rectangle, so we know how the 30 centimeters is split up. The opposite sides of the rectangle are equal. The top line is 25 centimeters.
Of course, well done, Ben. So, we subtract 25 from 30, which makes the base of the other triangle 5 centimeters. Now we use Pythagoras' theorem again. I'll race you, Ben. Who can find that missing side the fastest?
Sally toch, 13 centimeters. Now we have all the sides, so the perimeter will be equal to 15 plus 25 plus 25 plus 13 plus 30, which is 83 centimeters. Do you agree, Sally?
No, I don't.
Where did I make the mistake?
The length of the bottom side is not 30. You have to add 9, so it is 39 centimeters altogether.
Oh yes, careless errors are easy to make. I must check carefully. Of course it should be 39. Let me recalculate quickly. Perimeter is equal 15 plus 25 plus 13 plus 39 equals 92 centimeters.
Good work, you two.
It wasn't so bad. We just need to work one step at a time.
Viewers, before we see how the friends manage, let's talk about the area of a trapezium. It's not at all difficult. Just remember the formula we used before for a parallelogram. As long as you know which two sides are parallel, you can also work out the area of a trapezium. Remember, in these diagrams, h is the perpendicular height. The area of a parallelogram is base times height. The area of the trapezium assumes that A and B are the lengths of the parallel sides, and h is the perpendicular distance between the parallel sides. The area is the average of the two base lengths multiplied by the altitude or height. We write it as area is equal to half of the sum of the parallel sides times the height.
Let's do some examples. And now we can try to find the area of a trapezium. Let's use our first trapezium again. The bases are 4 centimeters and 8 centimeters, and the height is 5 centimeters.
Wait, we have to find the area of the parallelogram first. There are two trapeziums next to each other. The area of a parallelogram is base times height. The whole base is 12 centimeters and the height is 5 centimeters. So the area would be 12 times 5, which is 60 centimeters squared.
Continue, guys. You're doing well.
But now, the area of one trapezium will then be half of 60, because we put two trapeziums together to form the parallelogram. So the area is 30 centimeters squared.
Right.
But we can't always draw two trapeziums and change them into a parallelogram. There must be a way to derive a formula from what we have.
Are there any clues in the instructions?
No, we have to discover it ourselves.
Let's think. The formula for the area of a parallelogram is base times height. Now, the base of the parallelogram is 8 centimeters plus 4 centimeters, which gives us 12 centimeters.
In the formula for the parallelogram, we had base times height. So, if we replace the base with 8 plus 4, we're actually adding the two parallel sides together. 8 plus 4 gives 12 centimeters. The height is the same, which is 5 centimeters. Now we just need to divide everything by 2, or multiply by half.
So the formula will then be half of the sum of the parallel sides times the height.
We've got it. Half of 12 is 6 times 5 is 30.
Squared centimeters, remember?
Yes, of course. Great stuff. Let's use just this formula to find the area of the trapezium.
Okay, the formula for the area of a trapezium is half of the sum of parallel sides times height. The parallel sides are 4 and 8, so it will look like this. Area is equal to half, open bracket, 8 plus 4 close bracket times height. And that gives us half of 12 times 5, which is 6 times 5, which is 30 centimeters squared.
And taken the other way, we add up 8 and 4 and get 12 times 5 is 60. And half of 60 is 30. It's the same answer.
I feel very clever now.
Okay, let's do one more example using the new formula.
Okay, it reads, calculate the area of a trapezium where the height is 4.1 centimeters and the two parallel sides are 2.9 centimeters and 6.8 centimeters respectively.
I just want to write down the formula again. The area of a trapezium is half of sum of the parallel sides times height.
Well done.
Shh, I'm concentrating. So in brackets, I have the two parallel sides, which are 2.9 and 6.8. So I calculate half of 2.9 plus 6.8 times 4.1, which is the height. Half of 9.7 is 4.85 times 4.1 is 19.885 centimeters squared. To one decimal place, it would be 19.9 centimeters squared.
Now I feel good about this work.
Are you guys ready for tomorrow then?
Totally.
Viewers, this was lesson 4, which means we have only one more lesson on mensuration. Can you still recall what mensuration is? It's the measurement of geometric shapes. Here's a quick revision on how to find the perimeter and area of a trapezium. For the perimeter, you simply add all 4 sides together and that would give you the perimeter. The unit is centimeters. The area formula is derived from drawing 2 identical trapeziums and turning one around so they form a parallelogram. The area of one trapezium is then half of the parallelogram. The formula for the area is half times sum of parallel sides times height. The unit is centimeters squared. Please memorize all the area formulae. It is very important to know your formulae, as they will make the exams very easy for you. Before we go, here is our SMS competition question. The keyword for this program is, of course, trapezium. SMS your answer to the number 5003. Write the keyword trapezium with only the correct letter for the answer, A, B, or C. The question is, what is the formula to calculate the area of a trapezium? Is it A, half times base times height, B, half times base plus height, or C, half times sum of parallel sides times height? We look forward to the next lesson. Until then, bye.